thank you for taking the time this morning to uh, listen to me. In this talk, we're going to be talking about email phishing and how phishing is very pervasive in the security community and the damage it causes to organizations year after year. Obviously, we've all been maybe not always a victim, but we've all seen phishing, spam, and things of that nature. And a lot of people recommend that we educate our staff and users, and I wholeheartedly agree with that. But we wanted to take a little bit more, or we wanted to do a little bit more here in this webinar, in this workshop, to go a little bit deeper in how do we analyze phishing emails, how do we extract indicators of those emails so that we can understand the campaign, how targeted is it to us, and then what are the things we can extract from it that we could use for our preventative measures. Simply put, how do we stop these phishing emails or campaigns from continuing their success in our organization? I'm just going to sort of like throw out the hard truth there up front. This is a constant battle. One we're probably not going to win per se by saying, and winning meaning we're going to block all phishing. I don't think that's possible. But what we have to do is we have to continue to monitor this type of email activity. We have to continue to analyze it, and we have to continue to improve our preventative security controls to stop that traffic. Let's get into it. So why phishing? Why do we want to talk about phishing? Beyond the things we just talked about, it's something that everybody experiences, and by the Verizon data breach investigation report for 2020, we can see that in incidents, it's the second highest attack vector used, and then on actual breaches, we're dealing with it being the #1 vector used. So what's the difference between an incident and a breach? An incident is simply a security event that has a potential for exposure of your proprietary data, your systems, and unauthorized access. So it's the potential. An adversary is trying to attack your systems, but they haven't gained access yet. It could be a misconfiguration of a system that exposed something. Perhaps you've heard a lot lately regarding cloud storage. There's been a lot of issues in the past with people putting their data in the cloud, Amazon S3 being one of them that comes up quite often, and people forget that they've made their data publicly accessible. So that's a misconfiguration that potentially leads to an incident, right, where the possibility of exposure is there. A breach, on the other hand, is when you have a confirmation that vulnerability has been taken advantage of. Somebody has gained unauthorized access and they have acquired data or access in your network. So looking at these two, phishing is a very serious concern for all organizations because it represents one of the easier methods to get into a network. And what I mean by that is it's much harder for people to create malware and or write their own exploits or 0 days, meaning exploits that are unknown previously to the community, to attack a network. Those things do exist, but they require more skill and knowledge. So there's a less percentage of malicious adversaries using those techniques. Whereas phishing, in conjunction with some social engineering or the manipulation of social norms and the psychology of manipulating people on top of the technical skill of crafting malicious emails, provides a really, really fantastic way into an organization, because all it takes is one user to engage with a phishing email for potential incident and or breach. Anecdotally, on a lot of assessments we've done here at Level Effect, we've done some phishing engagements, a part of red team operation engagements that we've done, and we have about a 1% success rate with our engagement or victim engagement with our phishing campaigns. So if you think nearly a 1% engagement, which is really, really good, out of 100 people we send an email to, statistically, we're going to get 1, or 1,000, we're going to get 10. And we only need 1 or 2 people to really provide us the value as far as an access potential is concerned for us to gain that unauthorized access to a network. So the difficulty from a defender side is that when it comes to phishing, we have to be successful 100% of the time, which isn't realistic, unfortunately. So we have to be on top of our game. We have to be doing proactive analysis of email communications that are coming into our network, and we have to be extracting the key indicators, the key behaviors of these targeted campaigns, and building out our preventative controls. How do we block this type of traffic? How do we improve our spam filtering technologies? Or do we need to acquire a technology? Do we need to acquire a tool to add into our repertoire of preventative controls to block this malicious email? So with that being said, let's have a little humility here. If you guys can, I think you have a little digital hand. You do, a little clap hand. Can we get a show of claps, but if any of you have clicked on an email that you found out to be a phishing email, you were duped into clicking on a potentially malicious email. And I'm going to start off saying I definitely have, right? Some of them are really, really well crafted. And what I think is really interesting is even people who are well trained and versed at looking at these phishing emails will still fall victim because there's so much going in our lives that are situationally dependent that lowers your guard that we don't think about. Like in the example that I have for you in class here, it's a real phishing email that was sent to me regarding my Netflix account. And what was so weird about it and it caught me off guard is I was having DNS issues with my home network and I couldn't access Netflix. And I got that email like literally minutes after I couldn't access Netflix. And it was just luck of the draw that this email came in saying, hey, we're having trouble processing your payment on your account. And it just sort of came in and my guard was lowered. I'm already trying to figure out why is this not working. And I open up the email and I'm immediately like, I was really close to clicking. I'm sort of frightened at how close I was about to click that email. But then again, I took 2 or 3 seconds and I noticed a few key things and realized it wasn't legitimate. So we're going to be sort of walking through that email and talk about some of the things I saw and then what I did post that initial shock that, hey, this is probably not legit. And what I did to sort of get some additional information and context about that message. But there's a lot going on here that is beyond just the art of crafting an email message and sending it to people. Whereas the Netflix example here was just really lucky that they sent it when I was having legitimate Netflix issues. That does lead to a attack technique called pretexting. So pretexting is the process of setting up a scenario, and it can happen in many different ways, but essentially pretexting is building a more elaborate narrative, and the adversary, the attacker, assumes a role. They are socially engineering you, one, but they're also helping build a narrative around the delivery of their exploit, right? The exploit is, a link they want you to click, and the exploit is you clicking it. They're exploiting you. So pretexting, an example could be if I found the phone numbers and emails of users I wanted to target. I could call them and pretend to be a Netflix representative, and I could research, how does Netflix do? I could call Netflix myself. Looks like we have somebody. There we go. Adding somebody. So I could call as an attacker Netflix and I could learn how their customer service handles things. I could learn the things that they say. I could mimic that. And in doing so, I could pretext this narrative to my potential victims. I could call them and I can say, hey, I'm a representative of Netflix, yada, yada, yada. And during my phone call, I could send them an email. And I'm able to, because I'm talking to them live, I'm able to sort of alleviate any fears they may have about that email and improve the likelihood somebody may click it. So that is just one example of pretexting, really just having any narrative that you go along with your campaign to gain access is generally what pretexting is. But email phishing and targeted phishing isn't always just an email. It can be sent through various means, and it can use more targeted social engineering, and adversaries may reach out and call you, or they may send an email that is completely legitimate first to sort of soften you up. And I've done that in engagements. We masqueraded as an IT department for an organization, and we didn't ask the user to do anything. We just sent out an update bulletin. It was fake, but it was about a Windows update was going to be coming soon. We didn't ask them to click anything. We didn't ask them to download anything, nothing like that. We just sent it to them, and we waited 3 days. Because now we already had this narrative that they've already seen a message from us. We're not just people out of the blue. And we were then able to respond to that email to our target victims, then asking them, hey, now it's time, as we said, 72 hours ago, we're doing this update. It's now time to update your Windows 7 machines, download this binary and install it. And we use a little bit more official language than that. But we had, at about 50 people we sent, we had about 9 people download our Trojan and install it, giving us access to the network. And that's just another example of pretexting with social engineering. It requires a little bit of research, and it requires a little forethought in how do we reduce the stressors people may feel when they receive emails that they don't know, right? Users are getting pretty good at receiving an email and sort of like, okay, you want me to do something right now, and I'm going to take a minute to think through that. So anything we can do to educate our users and taking a few seconds to stop and read what's going on before we just blindlessly click is the ultimate goal here. So that's my very long narrative on I have clicked on spam messages in the past. I have fallen victim to them, but it's going to happen to everybody. We just have to be prepared for when that happens and then what we do next. And we're going to cover some of that in this webinar. So let's really quickly cover SMTP, how email works. And this isn't a deep down technical interview, it's more of broad strokes how email works. I just want to make sure that we understand how email communications work. So when we talk about some of these security controls that have been bolted on, it provides a little bit more context as what we're seeing in an email, right? Because us as recipients or security professionals who are analyzing a potential users in our organization's email, we're looking at this email message as a recipient. We don't get to see the midpoint traffic. We certainly don't get to see where it was sent from. We're not on the adversary's computer. We can only see what we know. And we have to sort of go into that knowing that adversaries were able to manipulate things prior to us getting to us. So we have to do our best to extract details and information that would be most helpful for analysis so that we can sort of slow down these types of attacks, or at least mitigate from that phishing campaign from spreading to other users. It's going to maybe hit one user and they might click it, and we can deal with that, but it's going to be much harder for a security team if 20 people clicked it, right? We're not going to be able to respond to that effectively. So this is really just a race against time, and that's why we have to be very proactive on this analysis. So let's cover SMTP, the Simple Mail Transfer Protocol. The official RFC, the request for comment spec from the IETF, which is the Internet Engineering Task Force, materialized in 1982. Internet messages, well, I wouldn't say internet, ARPANET messages were sent as late as the early as the late 60s and early 70s. And essentially, the growth of ARPANET required that there needed to be a more robust, standardized way to communicate messages, these one-time sent communiques from senders and recipients. And we could see over here in this map here, that is literally ARPANET in 1982. The precursor to the internet was so non-complex for its time. What was complex for its time, in today's date, this is not complex, but at the time, you were able to literally map every node and every point on the contiguous, the continental US like we have here. So it really wasn't that many places that were sending these early email messages. And because of that, ARPANET was relatively a closed network. It was by academics, research institutions, private industry, government contractors, research organizations, and of course, the Department of Defense and the US government writ large. So you sort of had this closed hold network where everybody sort of knew each other. There wasn't a really big concern of like spam and phishing because, you know, there was to an extent really no anonymity in this early network. Everybody sort of knew where everybody's systems were and where they were coming from. So the initial versions of SMTP were designed for availability and integrity of email transmissions. We want to ensure that if I send an email, it gets there, and if it gets there, the user is able to download it and receive that message. And the integrity, if I send you a message, the text should arrive in the same manner in which I sent it. It shouldn't be corrupted, and if it is corrupted, the system and protocol should have a means to validate and correct some of those issues. So SMTP, first and foremost, was more about availability and integrity of the communication. And as such, security was really not even a forethought or an afterthought. SMTP was a clear text protocol. So any email you sent, if collected by a midpoint or third-party person, they could read everything that was being sent. So there was no form of encryption, even encoding. There was no authentication. There wasn't in the early SMTP spec, there wasn't even a way to authenticate to your mailbox. You just sort of access your mailbox because you knew your address and things of that nature, so you're able just to access it. And we went through some various revisions. The main revisions was that in 2001, the RFC 821 was replaced by 2821, and then in 2008 it was replaced by 5321, and then the latest being 2015 was RFC specs 7504. And I don't want to get into RFC specs because if you've ever looked at them, you'll realize that they're fantastic reading material prior to going to bed. But if you do take a glance, you'll notice that most of the specification changes have been about optimization and security, primarily security. Tons and tons of security have been added because obviously emails are being abused. People want to ensure that their communications are private. And we want to be able to authenticate and validate that I am the only authorized user to my mailbox. So all of these things have really been bolted onto the SMTP spec because when it was originally designed, like I said, there was no security on board whatsoever. So let's look at some of the key components of an email system. So we have the mail user agent, and that's the software that you use to draft an email. So if you're a Microsoft Outlook user, Outlook would be your MUA. If you are using an online email system, say you're in Gmail and you're drafting an email, Gmail would be your MUA. It is the software that is used by the user to craft, edit, and read email messages. We then have a mail submission agent. This is a piece of software that validates your email. It makes sure that your email is correct. It doesn't have any errors as far as formatting goes. The sender recipient is in the right field, all that kind of stuff. That's what the MSA does. And the MSA then, once it checks this message for any errors, it then passes it to an MTA. And our mail transfer agent is an SMTP server that does the relay traffic. And it does this over port 25. So if you're looking from a network traffic analysis perspective, you're going to see SMTP port 25 from an MTA to other MTAs. An MTA would then also send it to an MDA. And what dictates how many MTAs there are? That's solely determined by how the sender's network and the recipient network is set up. If you start to look at email headers sent from Gmail, Yahoo, even Office 365, you'll see in your headers that your provider has multiple mail servers. And your email will hit 2 or 3 mail servers before it even leaves the Microsoft or Gmail or Yahoo network and goes over the internet to the recipient's network. And if it's a private business, they may have 1 or more email servers, or if it's another online provider, again, they may have 2, 3, 4 email servers. So it's important for us to be able to analyze sort of the hops these email messages go, so we can understand how the potential malicious phishing emails are being sent to us, how they're being communicated and conveyed to us, because that might provide us some indications on, hey, we can block that known malicious domain or that IP, or we can put a higher level of untrust on that IP range. You know, if I get an email from any IP in that range, say it's a well-known IP range from that known adversaries use, well, we can put a higher level of distrust in that IP address range. So any email from there, we don't want to trust. So an MTA, again, is the server that transmits the messages, the emails, and MDA is the system that receives, if we're talking about the recipient side, it receives the email message and it stores that message in the user's mailbox. The MDA also responds to user requests to authenticate and acquire emails from their mailbox. So the MDA is also doing that. And I just wanted to add the note here that MSAs, MTAs, and MDAs can all be on one physical server, and in many cases, they're one suite of application or one suite of software in a singular application. And an example here would be Microsoft Exchange. So if you're in an enterprise network that uses Microsoft Exchange, your admins will create an Exchange server, and it is an MSA, MTA, MDA all in one. And you as a user would use Microsoft Outlook to craft and read your emails, and that would be the MUA in that example. So you could have a Microsoft Exchange network with Outlook on the recipient, and you could have a Gmail sender. Either way, you all have both parties have these systems at play. They just come in different forms and factors, and that's where reading the email header helps us understand generally how our sender's network was configured for transmitting emails to us. Do we have any questions at this point? All right, cool. So let's look at SMTP in action really quickly. So just sort of going through what we just talked about. From left to right, we have an email message being sent. We have the sender's computer with an MUA, so we can assume maybe Outlook.com or Outlook, the software, and they're drafting an email. They would send that to their MSA upon submission, and which would then be sent to the MTA and out to the internet. Now remember, if we're using Exchange, steps 2 and 3 would be usually one system instead of two dissimilar or separate systems. And once it goes out on the internet, it's when we're using the SMTP port 25 relay protocol. So this is where the MTA is relaying this message across the internet to the destination or recipient's mailbox, as we're trying to get it across the internet to who we need to get it to. And what this MTA does is the MTA uses DNS, the domain name system. And for those of you who are maybe unfamiliar with DNS, DNS is simply the phone book of the internet. It correlates IP addresses to human readable names, such as google.com relates to an IP address. Routers and networking devices need IP addresses to know where to route and send traffic to. So a router doesn't understand google.com, it needs an IP address. So just in the same manner, a mail server needs to know, hey, Greg at leveleffect.com. The MTA is going to take leveleffect.com and it's going to do a DNS lookup to find the IP address for my mail server associated with my domain. Once it gets that IP address, the MTA can now transmit across the internet to the recipient network MTA. And I just realized I have sender and recipient backwards in these two boxes. So just pretend that those labels are flipped. I'll fix that. Apologies. So it gets to the recipient's MTA, and it is checked to make sure that everything's good. The two MTA servers actually have in the SMTP, there's a setup where they do a hello. They have status codes where they say, hey, I want to send you a piece of email, and the recipient server says, yep, everything looks good. The sender you want to send that message to exists, that's good. And then the sending MTA begins, transmitting the message, and the receiving MTA processes it and logs that email and then sends it to the MDA for storage in the user mailbox, at which time the recipient gets a notification, hey, you've got mail, and they can log into their mailbox and retrieve their email message. So we talked about email security and some of the things that have been sort of bolted on and added to the standard SMTP protocol. SMTP has improved dramatically since its debut, and it's done so because we're getting spam, malicious spam, and various phishing emails sent to us. So people quickly learned that hey, not everybody has the best intentions out there. we have to start adding security to our emails. So on top of just encryption and authentication, which improve the confidentiality, integrity, and availability of the communication, we had issues with malicious adversaries masquerading as legitimate businesses. Years ago, it was much more common, and I'm sure we've all seen this, for you'd get messages and it would say, hey, I'm from Walmart.com, or more legitimate domains. That's much harder to pull off nowadays because of some of these security controls put in place. That doesn't mean it doesn't happen, but it's much, much harder to pull off that level of masquerading and trying to trick users. When SMTP first came out, you could literally say you were anybody. You could say, I'm the President of the United States, and this is from the White House, and there would be zero checks in place to validate or invalidate that message integrity and the authenticity of the author. So a few things that have been added. We've added sender policy framework. So we have SPF, and this is done at the sender side. So it's something that the sending domain would configure. We have domain keys identification mail, or DKIM. This is also something we do on the sender side. And then we have domain message authentication reporting and conformance. Say that fast 5 times. So DMARC, DKIM, and SPF are all security things that we can do, security controls that we can do as owners of an email domain. So I own leveleffect.com. We use Office 365 to send messages. I have configured SPF, DKIM, and DMARC for our domain so that when I send messages, I'm validating who I am. I'm informing the recipients who should have sent the message from a server IP perspective, domain perspective, and I've provided insight or suggestions to the recipient on how they should handle the messages if they weren't processed accordingly. So let's pull that layer back and talk about that a little bit more. And first and foremost, SPF informs an MTA, a recipient MTA, of where should or what are the approved domains and IPs that should have sent this email. And let me give you an example using LevelEffect. I've sent all of you emails upon you registering for this workshop. Your email servers, your MTAs, when it received that message, it said, how do I know this is Greg from LevelEffect? I have nothing to corroborate outside of what's in this email message. So your MTA, when it does a DNS lookup, in my DNS records that I configured, because I own that email domain, I have an SPF text record. And the SPF record states the only servers that will be sending emails on behalf of LevelEffect are Microsoft Outlook servers from Office 365. So first and foremost, your recipient MTA can say, okay, this message, if from LevelEffect, should only come from this network, and they do. I've corroborated that from DNS. I've looked at the IP address ranges. They match. So the message is coming from the network that is approved. So we've passed our SPF check. We next have DKIM. DKIM uses cryptography to put a digital signature in every email that is sent from that domain. So LevelEffect has a public key that is available in our DNS record, and we watermark every email that we send with a DKIM crypto key. And just like SPF, when an MTA receives that message, it says, hey, does this email message support DKIM? Oh, yes, it does. Here's the DKIM key. I'm going to corroborate this key with that domain to see if they have a DKIM text record. So it does, again, it would do it in the same DNS lookup it did previously, but it'll look in that DNS lookup for LevelEffect and see that there is a DKIM record where I have my public key stored there. So it's able to corroborate that this key that's embedded, or sorry, this digital signature that's embedded in the email matches my public key. So I'm now authenticating that leveleffect.com is the verified sender of this email message. So we know the email message is coming from a trusted network for LevelEffect. We know that is now signed with a digital signature by LevelEffect. So we've passed those two security checks. And that really reduces the likelihood that a malicious adversary can just make an email and say, oh, I'm LevelEffect. I want to send it to all these potential students and get them to go to my fake course and have them download malware. That's less likely to happen because of the controls we put in place. And these are the standard business practices that every email domain should have configured. And I say should with asterisks because not every email domain is configured with SPF and DKIM correctly. Like anything, they can be configured, but they can be misconfigured where they're not optimally used and working as intended, and thus you've given a wedge, you've increased your attack surface for an adversary to get in there and to abuse that system. Last but not least, we have DMARC, and DMARC provides more of a framework and, like it says, a reporting and conformance on how we handle domains or messages that might have failed SPF, DKIM, or some other internal policy that we set up on our email systems. So what this really means is if I send an email message and let's say my DKIM is not set up correctly and it goes to another email domain and they say, hey, your DKIM's broke. Before DMARC, they wouldn't tell you anything. That email would just be dropped. It would never be remediated and resolved. So now if both sender and recipient support DMARC, the recipient email server will actually send a message back to the sender saying like, hey, you failed DMARC authentication. So we get that notification as an email admin, and we can work on resolving our issues. It also works well if somebody is trying to masquerade as us. And hypothetically, what if somebody got our private key for our DKIM? They would be able to sign emails as us, but they don't have their email server hosted where we do. So they would fail SPF but pass DKIM. DMARC would still send a message back to us saying, hey, you passed DKIM, but you failed SPF. Your email's coming from this IP. And we could then look into that and say, well, that's not right. That shouldn't have happened. What's going on here? And we'd be able to start doing our investigation. So that's how those three things really help secure email transmissions from a transmission perspective. Authentication and encryption help the integrity and availability, but SPF, DKIM, and DMARC are meant to restrict the likelihood that malicious actors are going to abuse it. But it's very easy to get legitimate SPF, DKIM, and DMARC and still phish us, and that's what we have in this example in the Netflix email we're going to look at here shortly. But before we get in there, we want to look at email header analysis, and that's going to be sort of what we're going to be doing a little bit technical hands-on here. So a few key points. Whenever we read email headers, we read it from the bottom to top, because as we saw in our diagram, emails are sent from the sender to an MSA, to an MTA, to an MDA, to the MUA, right? So we have all these different steps and hoops we have to jump through. So the record as it's written, the header of the email transmission starts with the very first transaction is written first, and then every subsequent transaction is added on top. It's added to that message. So we want to read from the bottom to the top, and whenever we see the field received from, that is the server that sent the message. It's like saying, hey, I received this message from that email server, and the byline is who's receiving it. I've received it from Gmail by Outlook, right? That's an oversimplification of the email strings, but that's what's happening. Received from, where did it come from, by, who received it. So another good sort of trick to make this a little bit easier to read is whenever you see by, change it to. Received from, to. And that's another way you can read these email messages. So we want to just begin reviewing some inconsistencies, right? On top of the social engineering aspects, just we've all seen phishing emails that just look terrible, misspelled. They just look like quintessential phishing. But there are some that take the time to craft really, really well articulate messages that are hard to discern from legitimate versus malicious. But there are always going to be inconsistencies. We are able to look up SPF, DKIM ourselves manually. There are third-party tools you can purchase for your computer or your network to do some of these checks. Email security solutions that attach to your email server if you manage one. So some general inconsistencies Sender addresses, embedded URLs not matching sender domain. We're looking for any signs of encoding. We want to decode those kinds of things. And on top of that, we want to be looking for the SPF DKIM and those other security controls. So it's a combination of contextually who's sending it, how are they sending it, and what links do they have embedded? Do these appear to be legitimate? Do they match? Do all the domains match? And we'll talk about what I mean by that in a moment. And then a lot of adversaries will use encoding to obfuscate or hide some of the things they're sending. So we can use some online freely available tools to deobfuscate or decode those sections of the header. So in this analysis, we're going to use a few tools. We're going to use CyberChef for decoding. We're going to use Domain Dossier for IP and domain analysis. We might use an online epoch timer. Epoch is every second since 1972, so it's a long string of numbers, and we can put that in a converter to get the real timestamps or suspected original timestamps in the email. Adversaries can, of course, manipulate and change timestamps. And we may use the whois registry information to learn, whose domain is this, how was it set up, when was it set up, because that's very important. And again, an operational security reminder. During a real investigation, we want to make sure that we're not exposing ourselves to the adversary. If we specifically feel that our organization is being targeted by phishing campaigns, they're literally targeting just us, we don't want to go out and do things from an investigation standpoint that leak our IP address, where we're coming from, because it tips your adversary off that you're onto them, and what they're going to do is they may go quiet or they may switch tactics that you may or may not be able to detect. So detecting is still challenging to do, so whenever we detect something, we want to make our best effort not to tip off the adversary that we're onto them, because if we do, that might have been our only lead. They might switch up gears and do something more complex that we have no capability of detecting or responding to, and then now we're flying in the dark. So we don't want to squander our successful detection practices with sloppy operational security. And some things we want to do is we don't want to send traffic probes. We don't want to scan things. Hey, this domain is sending me malicious emails. We don't want to respond and send data back. We don't want to respond to the emails and say, oh, nice try, sucker, try harder. Like, no, we don't want to taunt adversaries. We want to use a VPN, a proxy, or even the Tor network, the dark web, to obfuscate where we're coming from if we are going to do that type of stuff. We want to use a virtual machine. A lot of times adversaries sending phishing emails are sending it with malicious attachments or links to download malicious attachments. And in some rare cases, they might have a zero-day exploit for a browser, meaning just visiting the website could compromise your machine. So we want to do this all in a virtual machine so that if it's compromised, it doesn't affect our physical assets in our production or testing networks. The best solution is to do all of the above, but do it in an air-gapped network, meaning do it on a system that is not connected to the business's production network. A lot of organizations actually buy a separate internet connection, or they'll even have like a 4G LTE hotspot that they connect to a laptop that runs a VM, so that they have completely a completely different network access point than their production network to do these types of investigations if warranted. Any questions before we get into the hands-on portion? All right. So this is a screenshot of the email that I had received right after I was having some Netflix issues. So it just sort of, it sort of catches you off guard, and you're more inclined to fall victim when you're not thinking clearly. We could see I received this June 17th. And what's interesting here is they have support@netflix.com, which would sort of make some people feel like, okay, wow, this came from support at Netflix. That seems legitimate, but it's also odd that in the same sender field we have summary center for at okiyabu.com as another sender. That's definitely odd there. And if you've ever looked up emails, if you've used Outlook or something like that, you'll notice that there's a display name for someone and then their actual email. And that's what's occurring here. The actual email is summary center4@okiyabu.com, and they've set it up where the display name is support@Netflix. So my email, which you guys have all received, greg@leveleffect.com, but my display name is Greg Ake, my full name, when I send emails, if you've received emails from me in the past. So it won't show my whole domain name, and that's my email service setting up my display name versus my actual email address. And that was just a sort of quality of life improvement for users, so they didn't have to read emails. They could say, oh, that's my friend's name. I don't have to remember their weird Gmail address. But an adversary is abusing that. They're making their display name support@netflix.com with the real email being this. So it's potential that some users would be confused by this and more likely to click because they see support at Netflix, when in fact it's just a display name. It's not the actual email that sent it. Whenever we get emails, just contextually speaking, that says, hey, something, this is social engineering at play here, where they're trying to get you to respond in the moment. Hey, something's wrong. You need to take action now. Something wasn't billed correctly. You're gonna, pay a late fee or a penalty or something like that. That's usually the play here. And it says, hey, your account is on hold. And that's what really threw me for a loop, because I was having Netflix login issues. So when I got this, I was like, wait a second. And it's basically saying, please update your payment details, and it provides a link directly to the email, or sorry, a link to go repay. Netflix, if you've seen their emails, doesn't do this. And even if a legitimate sender, a legitimate company that you work with sends you emails that say, here's a link to go pay, don't ever use that. Here's the first and best thing you could do for yourselves and teach anybody else. If you ever get an email that you did not expect, it just out of the blue says, hey, something's wrong. If you get any email where you say it's something's wrong, like put it into that category. It's not saying, hey, you're awesome. It says, payment issue, something's happening, you need to log in, your password's an issue, somebody has accessed your account. The Instagram ones are really popular. Hey, somebody's accessing your Instagram. And a lot of people fall victim to those because they, and they're caught in the heat of the moment, and they're worried that, all their pictures of food on Instagram are going to be stolen from them. So they've got to, secure that immediately. So a good practice here is if it's anything that wants you to do something, never engage with the email if you didn't request it. Immediately go directly to the website. On your phone, log into Instagram and check your security settings. If it's Netflix, log into Netflix and check your account. And that's what I did. I didn't click this email. I went to Netflix, checked my account, and hey, everything's good. And then I went to Down Detector, a website that tells you if a website's down. I typed in Netflix and it said, yes, some people are experiencing issues with Netflix. And I was like, okay, that's what the issue is. It's not this email. That's just luck of the draw that they sent it around the same time I was having Netflix issues. So just the best thing I could say is whenever you receive an email like this, put it into the, it's something wrong category. I need to take action. So is it asking me to do something? Did I request this? Is it saying something's bad? If all those three check, go to the source yourself. Go to Netflix, go to Instagram, go to your Facebook, go wherever it's saying your bank account, go directly to the domain you know and trust, and manage your account there. Never work and respond through an email. It's too easy to manipulate people and catch people off guard via email. If anything, use email as an indicator on when you should check something. Never use it as your source of responding. So we can't really see it here, but some of the issues I had with it, it appeared there was a legitimate Netflix and a suspicious email, so we've talked about that one. These embedded URLs here, if you hover over any of these without clicking them, you'll see the true email or true link it wants to navigate you to. And they wanted me to go to manif, manif.hetigus.com, hetigus.com. So that's where they wanted me to go. Definitely not Netflix. So that pretty much right there says, this is bad. The weird email, the embedded links that don't go to Netflix, heck, the links don't even match the sender's domain. So we have a sender domain from okiyabu.com, which is completely dissimilar from hetigus.com. Clear signs that something bad is going on here. The logos that were included in this message, the Netflix logo, and there's one in the footer down here I didn't capture in the image, but those are hosted on Shutterstock. So if it was really Netflix, they would be hosting it on a Netflix server or a Netflix system. They wouldn't be hosting their own logos that they're using in emails on Shutterstock. So the totality of just that contextual information, just highlighting with my mouse very quickly was able to determine that this in fact is malicious. It's not legitimate. This is an attempt to get me to log in and provide over my payment details, right? Most phishing is financially motivated. And here's a prime example of someone trying to steal my credit card information. So let's dive a little bit deeper into the email header. So right here, I provided a link, and it's going to open up a new tab for you. I'm going to change my share view so we can get my full screen here, but I'm going to click that, and it should open up an email header. I'm going to share my screen here really quick. I got to move a few things out of the way. I'm going to pause sharing. All right. So on our right here, we have this email header. Let me see if I could zoom in over here. There we go. And we just want to do some initial checks. We want to start looking around and stuff. And like I said previously, we read from the bottom to the top. And as you can see, email headers are very, very noisy. But there is a method to the madness. We'll start to break this up here in a moment. But let's just go to the bottom, and we can see we have a bunch of random text. And this looks like base 64 encoded messages. Base 64 is a very common encoding scheme used for emails and other transmissions. The reason being is base 64 allows us to send binary data in text format. Remember, SMTP, very old protocol, clear text, it was designed to send ASCII text, letters and numbers. But modern times you want to send an email attachment, a file, an image. That's binary data. So we use base 64 to send binary. We also use base 64 to encode text to make it more compressed and efficient. So you could think of it somewhat like a zip file where we want to improve the performance or decrease the size of a message we're sending. So what we can do here is carefully, we're going to go to the bottom, and we're going to, where we have those two equal signs, and that's a telltale sign of base 64, by the way. We use these equal signs for
Hey,
padding
Greg,
in our messages. Yep.
sorry to interrupt, but we're not seeing that.
Oh my goodness, look what I had to do there. I had to click resume share.
Thank you.
My apologies. So at the bottom, if you scroll down, we see all of this text. Hopefully you were following there, this random text, and we see it has these two equal signs at the end. That's a telltale sign of base 64. It uses these equal signs as padding. Base 64 is supposed to have a certain number of characters per row, and it wants to have a well-defined amount of characters in the overall body, so it uses these to pad the end. So we're going to start just highlighting, and we're going to scroll up. It's quite a lot of text. So we get to the top, and we see right there, we get right to there where it says MIME version 1. So I'm going to right-click and copy that text. And what we're going to do is the first thing here, we're going to open up CyberChef in Foundry. I have the link there for you. And CyberChef is a really cool tool. It supports a ton of encoders, decoders, date format conversions. It has some decryption capabilities. It's a really, really great tool. And you make recipes. You're able to drag and drop these things in here to have it do in sequential order a number of things. We could have text like this that's base 64 encoded, that then is XORed, that then is ROT13 encoded. So we can just drag over all of these things in order, and it will decode it in order to get to some clear text or the final intended form of it. So what we're going to do is we're going to go to this input field, and we're going to paste that text. And we can see the output there. It's exactly the same. Nothing has changed either side because we don't have a recipe. And we expect this to be base 64. So we're going to go to from base 64, and we're just going to drag it over. And we can see as soon as we do that, this random base 64 encoded text has now turned into HTML content. This is the body of the email. So we're able to see how this email was configured. We can see some of the scripts that were used to make it look the way it looks, like a little website. We can see here it's referencing Shutterstock for the image. So this is essentially the raw source of what our browser is showing us when we view this message. So that's how we can begin to looking at this message body. There's really nothing in here we want to really go too deep on. I just wanted to articulate and show you that there was some base 64. Here's another example of base 64. Looks like there's some kind of a hash. So we could just copy that out just as an example and place that again. And you can see here, we get some really weird stuff. This does not look decoded. So there's probably something else going on here. And the challenge with this is from an analysis and investigation standpoint is we may not always know the order of operation that adversaries or senders have used to encode or encrypt their messages. This could be legitimate encryption, or this could be other forms of encoding that have further manipulated the text. And it's really experience and trial and error that allows us to sort of do that investigatory work. Hopefully, in many cases, there's threat intelligence that talks about phishing campaigns, and it's the community of very intelligent people who are analyzing all of these messages, and that sort of shared knowledge might provide insights into what the adversary is doing that we could sort of build upon that work. You know, we don't always have to go an investigation, you know, for the first time by ourselves. There is information out there on known adversaries, known phishing campaigns, and a lot of people are doing really good work to decode, understand, and convey what the adversary is doing. So we can benefit from that, and we don't always have to be sitting here by ourselves looking at weird output like this, trying to make sense of it. But again, this is going to be experience coupled with trial and error to try to figure out what encoding or encryption would be in use. It could be something proprietary. Who knows at this point? Any questions on CyberChef? It's a pretty straightforward, easy to use tool. I use it all the time. And that's how we can extract and, you know, decode information from emails, because adversaries a lot will use base 64. Another common attack is when an adversary gains access to a network, they'll use the scripting software PowerShell right here. This is PowerShell in a Windows environment, and they will run their commands base 64 because PowerShell natively can convert base 64. So adversaries use it to obfuscate their commands. Which, you know, a junior analyst or somebody who's not skilled in recognizing visually base 64 what PowerShell should look like may look over those types of commands happening in their network if they're unaware of what's going on. So base 64 is used in many areas of security, both for defenders and attackers across the board in many different ways. We have, it looks like we have UTF-8. And this is Microsoft's anti-spam message info. So nothing like too crazy here, but this is Microsoft labels messages received with certain values. So we're going to just come in here and we're going to copy this and see if we get anything from it. And we can see that this base 64 encoded is another string. Data is not a valid byte array. And I'll be honest with you, I have no idea what that is in relation to Microsoft's anti-spam message info. We'd have to go look up the tech support sites from Microsoft's anti-spam header information, and it's a very long article that explains a lot of these messages, but it's what's used by Microsoft to assess if this messages are spam or not. And as we've seen, it made it to my inbox, so, you know, I can't really give it a whole lot of trust, right, if it made it to my inbox. So it looks like it keeps saying the same thing. Just really quick, just see if there's anything else in here that may be of interest. Yeah, and it just keeps saying data is not a valid byte array. So there's just a bunch of issues with some of the data in here. Some byte data, there's apparently an issue that Microsoft has with it, but it doesn't appear anything that said, hey, this is spam, because if it did, I should have never received it in my inbox to begin with. It should have went right to my spam folder. So we're going on up here, and we can see these X header options. So you will see X header options in both SMTP and HTTP. The protocol is the protocol we use for web traffic. Anytime you make a request, click a link on a website, that's an HTTP GET request. So that's the protocol we use for accessing content on the web. But what the X headers are optional headers. They're not officially written into any RFC spec. What happened was is vendors and testers, they wanted to have a header tag that they could read. So they said, hey, let's make something that starts with an X and we only know what it means and we'll use it for our software. And it's become so pervasive that pretty much everybody, it's like not official spec, but it's pretty much treated as spec. And what happens here is Microsoft obviously is writing their own X headers. These headers are used by their software and their mail systems to read information about this, right? So X headers are strictly optional. Gmail doesn't have to read these. It can make use of the anti-spam mailbox delivery flags and some of these other things. It can totally make use of that, but it doesn't have to. It's optional. But we can see here Microsoft likes to make a lot of them. So just some that sort of catch my eye here. It's sort of saying the sender's IP is this IP address. So we have an IP address. So let's open up a notepad, right? It's always good to have a notepad with us when we're doing work so we can start recording stuff. So let's do sender IP, that one. Looks like we have the sender email address. We'll look at that one there. Just add it to a new row. And let's start going through this. We could see some things that sort of catch my eye here is this Amazon SCS. I can't remember exactly what SES stands for. Simple, Amazon, that's what we got. Google, always use Google. Simple email service. Amazon simple email service. That's interesting, right? So we've got Amazon simple email service being listed here. And we can see that it's SMTP out. So remember, whenever admins set up servers and they configure things, they want to use human readable terms that are easy for them to remember. You know, like having everything listed like something like this, you know, every new person that works for that company is going to be just like, what the hell is that? What server is that? What do we do with that? But SMTP out, anybody gets that context. This is an MTA server that sends traffic out. And it looks like it's using Amazon SES simple email service. And if I look up CA Central 1, well, what's that? That's a subdomain of interest, right? So let's go there and do CA Central 1. Canada. AWS's data center in Canada. Okay. So it looks like the adversary is using Amazon. So they have an Amazon AWS account where the Amazon SES service, the data center they're using is located in Canada, and they're sending SMTP messages to suckers like me. I bet this email address, or I'm sorry, this IP address might match Amazon. So let's check that. So if we go back to Foundry, I provided a link to Domain Dossier. It's a tool I use quite often because it allows me to do a few things really quick here. I'm going to put that IP address in, and we can get a domain whois record, a network whois record. Whois records are registration information. When you purchase an IP or purchase a domain, you have to provide registration information. I, Greg Ake, am looking to buy leveleffect.com. Now, there's a caveat to that. I don't want to be bombarded with spam and further messages. So I pay $19 a year to a company who manages my domain communication on my behalf. I don't see any of that junk messages that are sent to somebody trying to reach out to me. So it provides a level of anonymity when I'm, you know, managing or hosting a domain. Conversely, that provides a hiccup for us as defenders because I might have the IP or domain, but if it's being paid out and managed by a privacy provider, then I don't know the true recipient. There have been cases in the past where an adversary was dumb enough to register for a domain name using their Gmail account. And they would then use that Gmail account to sell software and malicious software on the dark web. So as you'd imagine, investigators doing research over time were able to correlate the Gmail to the website, and they start getting all these breadcrumbs. And this is essentially how like law enforcement makes cases. They find something, some identifier that they can track over time, and they start building that case until they get a warrant to get better data collection, and then they bring you down. So adversaries who know what they're doing will use privacy services. They will use proxies, VPNs, Tors. They will use virtual machines, so their physical computer at wherever they live or wherever they work from is not being leaked out. And of course, we use those same things in investigations to not tip off adversaries of what we're doing. So we're going to do really quickly, we're going to just check out this IP. I'm just going to select network because it's an IP address that's associated with a network. So I just want network registration information. And it comes back really quickly. And we can see here AWS email, Amazon Web Services. So yep, the sender is using Amazon Web Services. So here's a problem we're now dealing with. Here's the dilemma. We've talked about SPF and DKIM and how we use that to validate the sender. But we now have evidence that an adversary is using a well-known system to send the emails. Thus, Amazon Web Services has a valid SPF and DKIM. So that's sort of the things we're dealing with today's day and age. Cloud computing has enabled and sort of sidesteps in some ways some of these security controls. Back in the old days, just a few years ago, adversaries had to register and or manage their own email server, or they had to compromise somebody else's email server and use that server. So, excuse me, so it was much easier for us to do SPF DKIM analysis and say, hey, there's a mismatch, this isn't right, this is, programmatically, we could have security solutions just block this stuff before it ever got to us. But this adversary is using legitimate AWS services. I can't block that IP address range. I can't block AWS. It will, there's so many legitimate services that make use of this. So this adversary has overcome some of our controls that we would use to block them, right? We can't block them directly from the service, from the source, because we'd be blocking AWS. So, that's not good. We've got to find other ways to attach blacklists and block this user. So we can't block the IP, so that's not good. But there's this email, okayabu.com. So let's go up here and check out Okayabu. And because this is a domain, I want to make sure I have domain record turned on, like the registration information. But here's something you haven't seen yet, or maybe you haven't seen yet, DNS records. We want to select that. DNS records are the domain name server, the domain system, I should say. And this is how we correlate Okayabu to the IP addresses and the other types of records that our MTAs, routers, and other networking equipment would use to send and receive communications from this domain, right? Just saying, hey, computer, I want to go to Okayabu means nothing to the computer. It's going to say, I need a record type you want. Do you want to get an email record, an IP address record, and what do you want to return? Do you want an IP version 6? Do you want IP version 4? I need that information so I can send your message appropriately. So let's run okayabu.com. We're going to have DNS, domain, and network selected. And it should just take a second here. Looks like it's still loading up there. There we go. So it doesn't have an email, or it doesn't have an IP address tied to it. So there's not an IP address we can block for this domain, because here's another tidbit, a challenge. Many organizations can easily block IP addresses. A standard firewall that almost every organization has can block an IP address. You can log in as an admin. You can put an ACL that says, hey, if it comes from this IP block, you can do an ACL on your router. Hey, block this IP address, and it won't get into your network anymore. Your email server will not receive any emails from that IP address. But we don't have one here, and all we have is a domain name. So it's much harder for, not much harder, but it's not as easy to block a domain name, because the network security systems have to be able to open up the communications and read the message. And when you're reading a message from a network appliance level, you've slowed down communications, right? The network is now slower, so thus, to get faster systems that can process, reading into the content of a message being sent, read into the content of an email or web traffic, it costs more to have a fast one. So you sort of see the dilemma here. It's doable, but it slows down your network. And to have it not slow down your network, you need to spend a lot of money. So an intrusion detection system that can do it very quickly, you're talking $40,000, $50,000 for an appliance now that can then do content-based inspection. But having one of those, you can say, hey, any message that has okayabu.com in it, just block it, right? So that's what it affords you. Many organizations don't have that. Smaller organizations, many larger enterprises certainly do, but a lot of smaller organizations don't have these kinds of solutions, and they're struggling with that kind of stuff. So we could see here, Okayabu was created June 4th. This is also very, very suspicious. Whenever you have a domain that is very new, that's sending you emails that are A, unsolicited, B, are masquerading as a legitimate company, and then C, asking you to do something that ties to your payment or credit information, those all together are looking really not good. Because if we look up Netflix, for example, Okayabu is June 4th. If we look up Netflix, we can see, of course, a bunch of IP addresses. Hopefully in just a moment here, we'll get the DNS information. And we can see 1997. That's much more trustworthy. This domain has been out there and in use for a long time. And that just has more legitimacy, right? Adversaries who are sending phishing emails are constantly getting their domains blocked. They're getting blacklisted all the time. So they're constantly making new email domains. And whenever you get a message and the email domain is really new, right, that's just another behavioral indicator that, more than likely this isn't trustworthy. So if we go back to Okayabu here, and we go to Foundry, we can look up the MX Toolbox blacklist check. So let's click that. And here's a tool that basically checks a bunch of known blacklists to see if the domain or IP is on a known blacklist. Do people know it as being bad? And unfortunately, it looks good, right? So 8 blacklists, 0 listed, 0 timeout. So this isn't good, right? So this is how some security solutions use blacklists like this in making their final determination for allowing or unallowing an email message. And if we were relying solely on blacklists, we would see, how spam and phishing emails are making it through into our networks. So that's of concern to us. We can also look up the one email that manif.hedigus. So there's another domain we can look up. See if that one has any matches. And again, we're not getting any matches there. So that's really unfortunate that we're not getting matches to known domains. But again, adversaries are making domains all the time. Most of these domains are $1 or $2 a piece. And heck, you steal a couple of credit cards, you can steal a lot of money. Purchasing this infrastructure and domains is relatively cheap and accessible at that price point. So one thing that's interesting about this, let's go look up Hedigus in domain dossier. And again, it doesn't have an IP address. It was created June 5th, so one day. So we have, Okayabu June 4th. We've got Hedigus June 5th. We know it's from the same adversary. So there's sort of a trend here, right? You could see they literally built this campaign the beginning of June. They were setting up their email servers, they were crafting content, and I got it around the 17th. So they were, setting this up and having it done. We can see that domain names are pointing to Google because they purchased this domain through Google. Google, you can buy domain names through them. And just some other information tied to it. Here's the DNS records. So there's the name servers. These are the DNS servers that store information about the domain, right? So if you said, hey, I want to learn everything there is about Hedigus, we could go to Google Domains and ask it, hey, Google Domains, what do you know about Hedigus? Well, I know everything about it. Here's everything I know. And everything it knows is this DNS record. We can see that here's the primary name server. I know this isn't a DNS analysis workshop, but really quickly, let's go in here and see if they have anything. I was looking for a DKIM or I think Okayabu had the DKIM stuff, right? Let's see. Yeah, so this is Okayabu. Let's see if they had it. So there's a DNS key for a secure DNS. And they didn't here. I can't remember exactly where I saw it, but let's keep digging a little bit more into this. So that Hedigus didn't have an IP address, but one thing that we got here that we didn't get from Okayabu is we got a subdomain, Manif. Manif is a subdomain to Hedagus. And many times, Manif or a subdomain can be a completely different server. And you can have a domain name that exists out there, and this gets you to your general location. This is like saying, hey, I want to go to Google. Well, google.com will get you to, the construct that is Google, but specifically I want to go to maps.google. Oh, okay, well, you want to go to like this area of Google where map stuff is, or I want to go to flights. Okay, go over here to flights. And that's what's happening. So manif.hedagus is just some portion of the overall Hedagus domain. It's subordinate to Hedagus. So let's go look that guy up really quick. Oh, what do we got here? An IP address. Interesting. Because this is where they wanted us to go. If I clicked a link in that email, it wanted us to go to some website. Well, remember, my computer is going to say, hey, computer, I want to go to manif.hedagus, and the computer is going to be like, I have no idea what that means. I need to go get you an IP address to make that transaction work. Thus, the adversary has to have an IP address, right? So we saw on Hedagus, they didn't have an IP. They didn't set it up to a server. They're not pointing it to anything, and they don't need to because Manif has an IP address. So an unskilled defender might say, oh, block hedagus.com. Well, that's not blocking any IP traffic. There's nothing correlating. When your system is trying to say, oh, we're going to block Hedagus, I need to find the IP so I can block this IP. Well, there's nothing there. It's not blocking it. So Manif, on the other hand, does have an IP address. So that's interesting. So let's just copy that guy, add it to our notes. Ooh, wrong one. Manif, Hedagus. We'll just copy that one IP address. There is an IP version 6 there. Well, let's get that too. Why not? We'll be thorough. And let's go look through manif.hedagus, see if there's anything here. It says the canonical name, which is an alias. It says it looks like it's hosted on Google hosted. It might be a Google hosted website. We could look up that IP address. Here's something interesting. Here's an SPF. There's an SPF record right there. So typically an SPF record, let me zoom in here. An SPF record will tell us specifically an IP address or domain name that should be sending the messages. They're literally saying all. Now, an adversary is doing this because he's constantly getting blocked. His IPs are getting blocked. His domains are getting blocked. So he doesn't care where his messages are coming from because he's malicious. He doesn't care about security. But recipient networks, if they don't see an SPF, they won't process the email. They'll literally block the email address and not respond to it if they don't have an SPF record. So by this adversary putting an SPF record, they're literally getting through the SPF check. The recipient MTA will say, hey, yeah, they have an SPF record. They're good. The SPF -all matches the sender of where this email is coming from. And you could sort of see here, that's an abuse of the SPF record because SPF is supposed to specifically say, email should only come from this very specific location. The adversary is saying, I don't care where it comes from. And recipient systems are like, hey, that's fine. We could put a DMARC policy that says, hey, we don't want to trust -all SPF records. That might be a good thing to think about. But we would need to analyze that, how many legitimate emails use this tactic because they're lazy, right? They don't want to have email issues, so they put this in there just to get it to work. So that's unfortunately a reality of a lot of things going on. And is there anything else of interest in here that we haven't covered previously? Nope. And last but not least, let's just check the IP address really quick just to validate where it's coming from. Just going to do a network one really quick. And Google, good old Google, right? So again, they're using Amazon to send the email messages, and they're hosting their malicious websites that victims would be navigated to on Google. And that's generally at a high level how we would begin researching adversary infrastructure and what they're doing. So we can tactically block some of these IP addresses, but we have to know that it's hosted on Google. The adversary can shut their server down and that IP address will be leased out to some other legitimate user. So blocking IP addresses, it stops an attack right now, but it won't stop it tomorrow. An adversary in the cloud can change their IP address in seconds. In AWS, where we manage Foundry and all of our infrastructure, changing IP addresses, I think, is 3 button clicks in about 30 seconds. So if I was hosting malicious infrastructure and I got blocked, 30 seconds, I have a new IP address, and your IP blacklists are ineffective against stopping my new email spam messages. So really quickly, let's go talk about looking at email headers again and how to read an email header. So we were sort of in these X records. So if you ever want to get to the real email header, you know, the raw like MTA transmissions, go to the top of where you see your last X record. Remember, those are the optional ones. So we're going to go there and we see message ID. So this is an ID that's used for this message. Most MTAs, mail servers, put message IDs. And this is also how you, when you respond to a message, it uses the mail ID to keep, you know, your responses in the same thread, if you will. So we could see there's the reference to base 64. So that's also an indicator how we know there's base 64 information in here. We could see the subject, hey, your invoice receipt, renew your June membership, ticket number this, right? So that's the subject. We can see too, I changed my email address, but it was to me on Hotmail. I still have a Hotmail address. Don't make fun of me. My wife still has an AOL address I give her a hard time about all the time. And we could see here from, and we see this like weird stuff, right? At netflix.com. And then there's summary. Remember in the brackets here, in these caret brackets, that's the real sender. And we can see here, this is in these quotes, that's a string. This is the display name. And this is where that weird Netflix thing came from. So let's see how that works. Let's copy that, right? It sort of looks like something interesting here. So we're going to go to here and we're going to paste that. And we're getting, you know, hey, this is something wrong. It's because it's not base 64. If you notice here, it has a Q, and another common format is called quoted printable. And quoted printable is 2 characters separated by equal signs. And again, this is just experience and having exposure to it, but this is quoted printable. So if I go in here and remove this, I'm just going to double click the, I'm just going to click the clear recipe, and I'm going to search quoted, if I could spell, from quoted printable, we could see here it changes. So if I remove some of the stuff up to the Q, right, we want to just start getting where it starts the equals, we can see we get support at netflix.com. Let's see what happens when we remove that stuff. And that broke it. Yeah, so we can sort of see here that they use quoted printable to get support.netflix.com. Can any of you theorize why they used an encoding scheme to send support@Netflix as the display name? Why wouldn't they just type support@netflix.com as the display name for the sender? What do you think that is? Bueller? It's all good. Not sure. That's a completely reasonable answer. The reason being is spam filters. Spam filters are looking for well-known things that are used often, right? So a spam filter would say, support at Netflix. That's used a lot in spam. And the domain names in this body aren't matching Netflix. The actual sender, right? If we go back, the sender was okayabu.com in that image, right? So spam filters look at okayabu.com and then it'll say like, hey, your display name, where was that at? Your display name has Netflix. That's a mismatch. We're going to block it. But spam filters aren't smart enough to decode quoted printable. So an adversary is able to put an encoded domain or email address as their display name, and it gets past their spam filter. So this is a spam filter evasion technique. The adversary is using encoding to get past spam filtering, because if they just sent support@netflix.com, almost guaranteed this message would have never made it to my inbox. So adversaries have to try and try again, right? They are persistent and they persevere and they test things and they change things and they do encoding and encryption and they move and manipulate things around until it gets to work. And this is essentially why we're truly never going to win the cyber game. The whole goal of cybersecurity is managing risk to a reducing risk to a manageable level. Hey, we're getting attacked, we're having lots of incidences, but they're not becoming breaches. We're doing a good job. They're trying to get into our network and we're kicking them out faster than they can gain access. That's where we want to be. It's unrealistic to say we will block all the phishes, we will block all the hacks. No, that's never going to be a reality unless the fabric of the way computers, the internet, and people's and society changes, unfortunately. Because at the end of the day, if we're fighting malware or we're fighting phishing, we might be doing technical stuff, reading technical things, but we're fighting people. A person created this, and when I block them, they're intelligent. They're going to find a way around it. They use quoted printable to get past spam filters, and it works in the year 2020. This is a super well-known encoding. I'm honestly surprised that the spam filters aren't decoding this and just blocking it. And that just lets me know how terrible spam filters still are. So very quick, we're really running short on time here. Let's go up and we're going to start looking for those received and bylines. Remember those? So we can see some indications of DKIM signatures being checked, right? So this is in the header information where the MTA servers are checking DKIMs for various domains, and they're trying to validate that the DKIM works. And if you look into this header now that you have it, I'd ask you guys to go spend some time and play with this. You'll see that the SPF passes. Remember, because he says it can be sent from everywhere. So of course SPF is going to pass because it said, we don't care where it comes from. So that's an easy pass. DKIM is going to work because if you look in some of these DKIMs, they relate to the malicious domain, but because you're malicious doesn't mean you can't have a DKIM. A DKIM is just a digital signature. So Okayabu does in fact have a DKIM, and it passed. So no problems there. There's also another DKIM in here for Amazon SES. So all the DKIMs are passing, the SPF is passing. Our email security from a transport perspective is essentially null and voided. And with a little bit of encoding, the adversary got through our spam filters, our last layer of defense, and it got into my inbox. And then the true last layer of defense is my state of mind and my awareness, right? Even knowing what I know, I still almost clicked it because I was dealing with the exact problem. I couldn't access Netflix, and it catches you off guard, and like that's all it takes. And this is why phishing is so scary for a defender's perspective, because you don't know. We can teach email analysis for users, not to this level, but just sort of what we first did, just looking at an email and saying, hey, there's some weird things here. We could teach that till we're blue in the face, but we don't know if somebody's in with a bad day, or they didn't sleep that night because their kid's crying and they just click something, and them just clicking something is now letting adversaries gain access to the network. And I will just add this other bit. Your security should be able to handle users clicking on things, even bad things. If your security team is literally saying dumb users keep clicking stuff, that's a poor security apparatus, right? Users are going to click things. Be prepared for it. Change the mindset, right? Because I've worked at many organizations where they're literally like, oh, if we just didn't have users, and it's like, okay, well, if we didn't have users on our network, we wouldn't have jobs because this wouldn't be a business making money. So I don't know what the solution here is, So we have to create security that expects the worst, and the worst is that users are tricked. Some are malicious users, insider threats. Some are just unaware, and they like cat pictures, and they like to click, those email chains if they're still around out there. They like them. So really quickly, let's look at our received and bylines. We could see a received from. So here's the server that sent the original message, right? There's our Amazon SES with the IP address by, and it follows with by. So remember, by, change by to 2. From Amazon to Outlook.com. So here's the first mail server, and here's the private IP address of that mail server. So it's interesting, we can also map internal IPs. We now know that Outlook uses 10 private IP addresses in their internal network. Really nothing we can do with it right now, but from an adversary perspective, maybe in the future that might be something. And we could see on initial receipt of that, it did the SPF. Hey, SPF passed because Amazon SES designates that IP as a permitted sender. So SPF for Amazon passes, of course. Okayabu passes, of course, right? So they're all passing DKIM because the DKIMs are legitimate for their domain. So it's all passing. So we could go up here. Remember, there's the AM6 server, the one we saw down here. It's sort of hard to read, But there's the server that first received it. If we go up a little bit further, here's all the DKIM security stuff that MTA agent, the recipient's MTA was checking. And then it said, hey, the server received it with Microsoft SMTP server, so it's a Microsoft server. And then we can see the next receive from line. So from that server by this one. So it went from AM6 Euro ending in 006 to AM6 Euro ending in T049. So we have the sender server, we have the first recipient server that did all the MTA SPF DKIM checks. It was then sent to this other server, and then we can see it sent it one last time from this server to this production one. And it has prod in the name, assuming production. So this is the final server that received the message via HTTPS communications. So there's 4 servers: the sender server, the first Outlook server that did the checks, the second server that received it after the checks, and that server basically sent it off to the final MDA box that stored that message, where I, of course, logged in and retrieved that message. And that's how that message got from Amazon to my inbox. And we can see that the SPF and DKIMs all passed, yet even though we know this is a malicious phishing email. So SPF and DKIM are great, but it's very easy to get past them with the use of legitimate services and solutions online. So let's go back to Foundry. I'm going to pause my share and pivot back over to my screen, resume share this time, and let's pick up these last few slides. So let's talk about the types of phishing. We've been using the term phishing a lot. Phishing is general communications that attempt to trick or confuse users to engaging via a download, click a link, or even respond to that message. And that's sort of with that Netflix ones. It's a general phish. So think of when somebody says phishing, they're talking about generally sending out emails to people hoping that they respond to it. Mass emails. So we would also maybe call that spam, but spam is usually referred to more legitimate businesses that are just being really annoying and just sending you just messages you don't want. Phishing is more malicious intent, if we wanted to sort of delineate between the two. Spear phishing is more concerning. This is when the adversary does target specific research. So I want to attack my company, Level Effect. Well, I have a LinkedIn profile. I've got friends on LinkedIn. You might be able to find some of my social profiles. You would social engineer me. You would learn about me. You would learn about my employees. You'd learn about what we do, the things we talk about, because there is a lot about us available online. All of us, there's stuff online. Think about a larger organization, a large business. I can find out their organizational structure, the heads of different departments from LinkedIn. Oh, I'm the HR manager for, Good Corp or whatever company it is. Oh, I'm the lead IT guy. I'm the security person. I'm the CFO. I'm the CEO. So we can learn who these people are. We can do research on their social media. We can visit the target's webpage, the company we want to spearfish, and we can see like what they do. One I've always used is I've had a few phishing campaigns I did around when people and businesses are doing their health insurance enrollments. So every year, most businesses, usually in November to December, are doing healthcare enrollments. And I've done a lot of investigations that were in December because it's usually a downtime and they just want us to do, not investigation, an assessment. And I've done a few phishing assessments where we phished an organization to see how resilient they were. And one that we've always used that was really successful is we did a little research and we found employees who had children. And not to like threaten anybody or anything, that's not going bad like that, but having kids myself, I'm always concerned with my kids' health and well-being. So we sent email messages basically saying there was an issue with your healthcare enrollment and your healthcare benefits, if not resolved, will cease on December 31st at midnight. And we'll send these around the middle of December. So as you'd imagine, the users are getting ready for the holidays. Some of them are traveling. It's a stressful time. People are shopping. So we're already dealing with people who are sort of off their game, if you will. And then we're sort of, coaxing them, frightening them a little bit that they may lose their health care, right? And that's, as a parent, that's very concerning. And we get a lot of people who click those a lot because we are socially engineering them appropriately using key triggers that would cause a response. And that works because I myself am a parent and I know what that would feel like receiving a message like that and how concerned I would be, and I'd click it and respond. And that's what adversaries are doing. They're abusing our state of mind. They're abusing the situation, the timing. And that's why spear phishing is even better, because it's tailored to the organization. In our email, we were able to use the company's letterhead. The company posted their healthcare benefits publicly online because, candidates want to get a job there. So we were able to use like the PDF attachments that the company legitimately uses, their headers. We were able to masquerade as legitimate users, the head of HR. We had the right phone numbers. We bought a domain name that was one letter off from their legitimate domain. So even if they looked at who it was from in the email, it was only one letter off, like an L to an I or an I to an L. Nobody, your eye's not going to catch a little change like that. So phishing, when it's targeted via spear phishing, is highly effective and very worrisome because it's so effective. And that's why we need to be very diligent in looking at communications to our organization that might be targeted and responding to those appropriately. Whaling is another form of spear phishing, but we're going after the big fish. This is where we do all of what we talked about in spear phishing, but we're going after the CEO, the CFO, legal. I was meeting with an investor 2 years ago. This was really crazy that I got to see it sort of like firsthand, just sort of the initial notification. I was having a lunch with an investor, and he was talking about a deal they were doing with a startup in China, and I think it was like $15 million deal. And we're having a good lunch, and about like 40 minutes into it, he gets a call and he abruptly has to go. And he says that the CFO was about to, and this is real, this like blew my mind that it was so interesting it was happening. He was about to do the bank transfer for the 15 million to the startup's bank account, and they had received a last minute email saying, oh, hey, yeah, our banking information, sorry, we did something wrong, here it is. And the CFO, when putting it in, he was like literally typing it into their bank portal, realized that the routing number was one number off from the known bank's routing number. Like, he went and corroborated the known routing number and said, wow, this routing number they gave us is one number off. Come to find out, there's many services online where you can pay for a one-time bank transaction where you can make up a routing number and account number of your choosing, as long as it's not a legitimate routing number. So the adversary got the legitimate routing number for the known bank, changed it by one number, used the exact same bank account number, and sent the email. They almost stole $15 million if it hadn't been for that CFO reading the routing number closely. So as you'd imagine, this happens quite a lot, going after whaling these big players. And that sort of leads to all these other questions. How did an adversary know we were about to make a huge transaction worth millions of dollars today? And how did they know the banking credentials of the startup we were going to invest in? It brings up a lot of very interesting questions that I'm sure that they were very sort of freaked out about that they had to go deal with. Then we have smishing. So smishing is phishing through text or SMS. I'm sure we've all gotten those texts where it's like, hey, here's a really cool thing with a shortened URL. Don't click those because they can compromise your phone. There have been many exploits that sent via text message can compromise your phone if you click the link. So please don't do that. But smishing is, again, phishing, social engineering through text and SMS. So what can we do for containment? We can blacklist IPs, again, asterisks, like we talked about. Blacklisting IPs on Amazon might be good for like in the next hour, but it is not. It's a piece of bubble gum on a leaking pipe. It's still going to leak. We want to get to blocking domains because, as we saw, Yake, oh, I can't even remember the domain name now, but the domain that the user sent from, right? The Hedagus and the other one, we could block those if we have intrusion detection prevention systems that can block it. We need prevention systems to block that, either in the network, monitoring email communications as they're being sent to our server. Unfortunately, many email communications are encrypted nowadays, so we're really looking for a security solution that is paired up with our MTR mail server that's inspecting these email messages and handling them accordingly. We need to administratively remove phishing emails from the MDA. So if we do get phishing emails sent to us, we need to go into the email server and remove them. We want to check our network logs. Did a user click a link? Because as you saw, when we did this analysis, we learned about the URLs, the IPs, the domain names. We could go look at our traffic logs if we have logs for our network to say, did a user go to that? Do we have any machine in our network that made a connection to any of these IPs or domain names? If so, we now need to start an incident, an investigation. What happened when they clicked it? Did some malware get installed? So now we have to respond to that. We have to go find that machine. We got to find the user. We've got to start containment. Hey, is this a legitimate breach? So there's a lot of work that goes into following up from a potential phishing email that that was clicked on. Most of the time, however, most phishing emails are wanting people to divulge credentials or credit card information. So not malware most often. It's a user went to a website and, hey, your Netflix is outdated, update your billing, and I've given them my new credit card information, and they rack up thousands of dollars and run on their merry way. So the best we could do as security is to inform that person, hey, you need to go freeze your credit, you need to go cancel that card. Here's any evidence you need, go create a police report. That's, now on the user, your credit card, your identity, whatever it is, has been stolen because you've unwittingly handed it over thinking it was legitimate, unfortunately. We want to add things to our junk spam folders. A lot of security solutions beyond just a junk folder. They have platforms where you post the message and it will learn some of the key things where you say, hey, this is a known malicious email, and you give it to it and it'll say, okay, cool, I've extracted these things. I've learned some of the things that this adversary did in this message. I will look for and or potentially block messages that are similar to this. So that's really what you get with a third-party product that you buy in your network, is it's able to take things you've analyzed and help you look for more that may match and help block against them to prevent. Prevention, utilize network intrusion detection prevention systems, as we've discussed. Use a specific security solution for your mail servers. Ensure antivirus is installed, configured, and updated. Configured, you'd be surprised how many organizations do not properly configure antivirus on their workstations, rendering them pretty ineffective. And make sure that they're updated. You have paid for their licenses. They have not lapsed. They're updated. Many organizations I've pen tested actually had an antivirus that was out of date. They don't update them. And that's not good because, well, it's good for us. It made it easier on our job, but it's not good for them because it's not doing what it should be doing. Threat intelligence out there provides other additional information. Other people are dealing with these phishing campaigns. They're sharing their insights and information. Security solutions can make use of threat intelligence feeds and embed that in your preventative tools, such as your endpoint solution on your computer, your antivirus or something like that, or the security solution on your mail server can be using or making use of threat intelligence to block known malicious emails and domains before you ever even have a chance to analyze it, which is great. We want that. And lastly, you got to keep educating, right? Users are still going to fall victim. Don't beat people up. But we've got to educate our users, and you have to provide a way for them to do reporting. I'm honestly still surprised how many organizations do very lackluster phishing awareness training, and many organizations don't have a single point for the company, for employees to contact them, such as a CSIRT, Computer Security Incident Response Team. So CSIRT at my company, hey, I think I got a phishing email, and you forward that phishing email to the CSIRT team, and the CSIRT team does their investigation, right? So if we educate our users and we provide a point of contact for them to send potentially phished emails to us, we can do what we're doing here. We can analyze them and make a determination of benign or maliciousness, and that helps us greatly in improving the preventative security against continued phishing campaign attacks. So last but not least, here's a shameless plug. Our Cyber Defense Analyst Bootcamp. If you found some of this content interesting and you enjoyed hearing me ramble on, you could do that for 13 weeks. It's virtual, online, remote. We teach it just like this, except we use Microsoft Teams versus Zoom. And the benefit to Teams is it's what I use day in, day out for my business. So you'll be able to talk to me throughout the day if you have questions or issues. So you get a very personal touch with being in the course that me and my business partner and our assistant instructors are readily available and right there to communicate with you. We cover a lot of topics. This is just, we've covered 1/1000th of what happens in cybersecurity and security operations, just phishing emails. There's a ton to it, and we cover a great deal of these roles, these jobs, these tasks, and these processes to remediate and respond to these targeted and sophisticated attacks. And last but not least, we have a Discord community. You guys all have access. If you want to click this link here, it will take you to Discord and you could sign up, and we share blogs, articles, things about job postings and things like that. It's a new community, so we're spinning it up right now, but we're looking to add additional information to it. And if there's no questions, that was it for this presentation. Thank you guys for showing up. It was a good time.